Alrighty, friends. So, on the heels of yesterday's exciting law of science notes, we're going to do a law of science day 2. There's kind of a tricky little bit to law of science, so we need to talk about that. We're also going to talk about how to find the area of a triangle. These are non-right triangles, remember, because when we have a right triangle and it has a 90-degree angle in it, our area can just be 1/2 the base times the height, like it was in geometry, the good old days, because the base and height are perpendicular. But when you have a non-right triangle, that is not the case because you don't know the height. So we have two other formulas. We're going to learn one in 13.5 and one in 13.6. This one's for, and this is flashback to geometry as well, when you know two sides and an angle. So let's say I know that I know this angle A, then I would have to know the ones next to it. Like this would maybe be B and this would maybe be C. I know they're not A because A is across from it. And in order to have side angle side, I need two sides and the angle that they form, the angle in between them. And in this case, to find the area of this triangle, I would take 1/2 and then multiply the sides by one another. So side 1 times side 2, and then times the sine of that angle. Now, they don't have to be A, B, and C, but they all have to be different letters regardless of what triangle you're in. You should never have a side and the angle of the same letter because you can't have the one across from it. You need the two on either side of it. So that's pretty straightforward. In fact, we'll look at that first because this guy up here is a doozy. So say you were given triangle ABC, and it tells you that A is 46 degrees, and it tells you that B is 14, and it tells you that C is 10. You have one of each letter, A, B, and C, so you're good to go. So you would be able to just go straight through on your calculator. 1/2 times one of the sides times the other side. It really doesn't matter what order they're in. And then times the sine of the angle that you were given. And so that is a straight up calculator process. So that's a lot of stuff. 0.5 times 14 times 10 times the sine of 46. So make sure you remember that part. And that tells me that the area of this triangle is going to be 50.35 units squared. I'm not going to really worry too much about the units at this point, unless it's a word problem and there's an application. So that is kind of what you do. I give you one more example if you're using the notes packet to follow along. You've got triangle Meg. So it gives you G is 11 and it gives you M is 7. Those are both sides because they're lowercase. And then it gives you that angle E, and I know it's an angle because it's uppercase and it has a degree mark. And again, I have one of each letter. So I know that I'm in this situation and I can go ahead and use that formula. So I'll have 1/2 of one of the given sides times the other given side times the sine of the angle I was given. And then a straight up calculator again, 0.5 times 11 times 7 times the sine of 120. The area of that triangle would be 33.34. So that is the area part of our notes, and that is super straightforward. It's just a matter of kind of adding this formula into your brain. This is only going to work with right triangles. This is only going to work if you have this information. And so you have to choose a triangle area formula based on what information you have given. All right, so let's do the real fun thing for today. And that is going to be something that is called the ambiguous case. So we protected you from this yesterday in day 1, but with the ambiguous case, and I'll do my best to sort of illustrate how this happens, there's a couple of conditions you have to meet for this to be possible, but the ambiguous case means that you could have two different triangles or you have no triangle formed by the numbers that are given. I forgot triangles. So hang in there while I kind of go through this a little bit. This is going to happen when, so this is kind of your checklist. You have been given two sides and one angle. So you're given two sides and one angle. If you haven't been given that, then you already know there's just one triangle and you're not going to have to worry about this scenario. The second option, or excuse me, the second thing on your checklist is that, and bear with me here, the side across from the given angle. And the way you're going to know that it's the side across from the given angle is that they're going to be the same letter, big A, little a, and so on. So if the side across from the given angle is smaller, meaning it's the shorter side than the other given side. So those two things have to be happening. So when you look at a problem, and this doesn't happen all the time, but if you were to take a test on the law of sines and it never happened, you probably did something wrong. So if you look at a problem and you see that you were given two sides, one angle, stop and then see, is the side across from the given angle, meaning the same letter, smaller than the other given side? If so, you are going to run into potentially a situation where instead of just having one triangle, you find the sides, you find the angles, you're done. You're either going to have no triangle, like the pieces don't form a triangle, or you're going to have two triangle options, and you will need to, in your answers, list both, meaning all the options for the angles and the sides. So how does that happen? Say you had a triangle and you were given this angle right here. So that angle is set, it can't move. And you were given this side right here, side 1. Well, then over here, let's say you were given side 2, and in this case, that would be A because it's across from angle A. So I'm in this condition. I have two given sides and one angle. So if those are the pieces of information I knew, and because both of these have to be true, the side across from the given angle is smaller than the other given side. So this side is longer, and that's a fixed value. This angle is a fixed value. This is like a pivot point, and this is the other given side, and it's short. And the question is, how short is it? Is it too short, or what's the case? And so if you were to imagine this kind of swinging through here, it never touches this other side that's also locked in place by that angle. And so if it's too short in comparison to this one, then you're going to get no triangle. How are you going to know? Well, you're going to set up the same as you would. You'll have the sine of A over the side A that was given, and then maybe you're looking for this angle down here. Let's call this one B, and so that would make this a B. Then I would be setting up sine B over little b. This would be the thing I'd be trying to find. I go ahead and I do my cross multiplying like normal, and then I'm looking for an angle, so I go to do my sine inverse, and when I do, my calculator gives me an error. So that's usually a really good hint that something's wrong. And so in that case, and I'll show you an example, I find out that, hey, there isn't even a triangle formed here. Like there's no triangle at all. Okay, then let's prepare ourselves for the other what if. Well, what if you have the same kind of setup? You have an angle that's fixed, and then you have a side here that's fixed, but then this side is just the right length so that when it starts to swing, again, we're kind of imagining it as a pivot point, it's going to come down here and hit right here, forming a triangle. That would make this angle B my first option. And then it's going to continue to swing through, but on its way back out, it's going to hit that fixed bottom line again. And now I'm going to have another triangle. So instead of this big triangle over here where B was a acute value, now crammed in the corner here, I'm going to have angle B2. And then my triangle would just be this part right here. So you have two possibilities. This angle didn't change in that swing. This side didn't change. This length didn't change. So the three pieces of given information didn't change. The only thing that changed was that if it stops here, I get a little bit bigger triangle. And then as it swings through, I also have this opportunity to have the smaller triangle. And you really don't know which one they're looking for. So that is the most dreaded situation because now you have to do twice the work. So I would have to go ahead and set it up. So what'll happen is I'll be doing the same thing. I'll set up the sine of the angle I was given over the side. Then I will set up the sine of the angle I'm looking for, that's the thing in question, over the side I was given. I'll go ahead and do my cross multiplying. And here when I go to do sine inverse, I'm going to go ahead and get an answer for B1. And that's going to tell me the angle measure of this first option. This first option will always be acute, meaning less than 90. Then that's going to drive my triangle. Like when I go to set it up, and I keep telling you guys that I set it up this way because it keeps me organized, I already knew this because this number was given. I know this because this number was given. And I know side B. Those were my 3 given pieces of information. What I just found is the information for this outside triangle. I just found the angle B for that. So I'm going to have to say, well, now I know that this is going to mean there's 2 triangles possible. And B1 is going to be some acute value. Then I'm going to find, because these total 180, C1. Then I can use the law of sines to find this length of the third side. But when I go to do, this is going to be triangle 1, I still have to say, well, what about that second option? What about if it's over here instead and you've got this little triangle? The things that will not change are the given. The A will be the same, little a will be the same, little b is the same, but now I have to find the second option for that. We're doing sine inverse. If you remember your 13.4 notes, the way you find your second option with that is to take 180 minus your first option. Super important to remember that. So for me to find B2, I'm going to take 180 and subtract what I got for B1. And that's how those are supplementary. One will be acute, one will be obtuse, and they will add up to 180. So then once I know this number, that I can find again that these total 180. So now that this got bigger, this C2 will get smaller. And then side C, I'll use law of sines. So this is the way that you do these, and I'm not saying it's super obvious or easy, so let's do an example of each. And I don't know, going into them, I'm not sure like what's going to be what. So I have here, it says to solve triangle GHJ, and this is off your notes again. This is number 4 if you like to follow along in the notes. And it's telling me, so I like to do this, GHJ, sides in my angles. It's telling me that H is 36 degrees, little h is 9, and little g is 12. Okay, so let me refer to my checklist. I have been given 2 sides and 1 angle, so check. The side across from the given angle, and the way I write them, it makes it easy, that's this guy, is shorter than the other. Yep, 9 is less than 12, so I am in this scenario where I am going to get 2 triangle options or no triangle at all. So according to my handy dandy notes, what am I supposed to do? Well, you don't really do anything differently. You just start solving, and then you have it in your brain that if I get an error, that means that that little piece was too little and a triangle is not formed. So I would say there is no triangle formed. Or I am in this scenario, and this one's the one that'll sneak up on you because when you get your first answer, you have to have it in your brain that you have 2 options. Otherwise, you're just going to fill in this part and go on your merry way and miss the entire second option. So I always like to look at the problem now that we know this is going to exist on our sheets and say, how many triangles is this going to be? So I look at it and I say, well, I met my 2 criteria, so this is going to either be 2 or none, and then start my work. So I'll set up sine of 36 over 9, because I always use the given one, and then I'll do the sine of g over little g, because that's all I know. So I'll do my cross multiplying, so I'll have 12 times the sine of 36, and then I'm going to be dividing by the 9. You can write it all out if you'd like to, but I'm going to skip some of those steps for time's sake. So 12 sine 36 divided by 9. Now keep in mind, that is going to be giving me the sine of g. So the sine of angle g is 0.7837. So since I'm looking for an angle, and just like it says on my notes, I'm going to end up having to use sine inverse. So at this point, I'm doing sine inverse of 0.7837. So inverse sine 0.7837 gives me an angle measure. So angle G is 51.6 degrees. Okay, so here's the sneak attack one, because at this point, I didn't get an error. So it's not the scenario where there's no triangle. This tells me there's going to actually be two triangles because I met the criteria and I got an answer for G. So let's think back to here. Now we have to set up the two options. We're right now finding this one that I told you would always be acute. So this just turned into my first triangle, and I'm going to have to add a second triangle. So these are twice the fun. You're welcome. Keeping in mind, when you set up for the second triangle, the things that don't change were the givens. That was given, the 9 was given, and the 12 were given. So the only pieces that will be different are the rest of the pieces that you have to solve for. So for example, here, we just found that this was 51.6. So going down to the other option, keeping in mind that with sine inverse, to find the second option, we take the 180 minus our first option. So to find that other second option, and again, looking back at my triangle, you're expecting that second option to come in as an obtuse, meaning greater than 90. I'm just going to go for it right away and go 180 minus that answer. So my second option is going to be 128.4 degrees. So that all makes sense because that is my obtuse option. Okay, then what was I supposed to do? Well, I'm supposed to remember that these total 180 in both cases. So here, I would have my 180 for the total triangle minus the 51.6 and the 36 that I already have. So that makes this option a 92.4 degree angle. Same thing down here, because this angle got bigger, I'm expecting that third angle to get smaller because now I've used up 128.4 here and the 36. So now angle J is only 15.6 degrees. Because again, if you look at this triangle here, this angle we found was acute, so the one at the top is a little bigger. But as you pinch down here and your second option for this angle becomes obtuse, this one becomes really small. So it makes sense to me that my J angle went from a 92 down to a 15. So then what I have to find in both is what is side J? And so the first option, I always go back to what I was given. So I set up the sine of 36 over 9 equals the sine of 92.4 over J. And I'm going to cross multiply. 9 times the sine of 92.4, whose bad writing is that? Divided by the sine of 36. So in this case, J comes out to be about 15.3. And again, this is my smallest side, smallest angle. Just kind of checking. This is my medium angle, medium length, largest angle, longest length. So I feel like that's right. Same thing down here. The only thing I need is J. I solve for it in the same exact manner. I like to use the given. So sine 36 over 9. And then equals the sine of J again, but now J has taken on a different value, so it'll give me a different value. So I'll have 9 times the sine of 15.6, close that out, divide by the sine of 36, and J2 is only coming out to be 4.1, but that makes sense to me because it's across from a really tiny angle. So if I kind of look back at this model we're using, that would mean this side got really small, which makes sense because it's across from a really small angle. So that is an example of one where there's two triangles. Obviously, that is a lot of work, and there's not going to be 1,000 of those, but you definitely need to know when that's going to happen. We have one more example that I'm going to just guess is going to be no triangle, but just so we can see that in action, it says I have triangle cat, again, Miss Meyer, T equals 32, so that's a side. A equals 24, and big A is 121 degrees. Okay, so I like to write that out the same way, make it really obvious to myself. Once we do law of cosines, this will come in really handy. So T is 32, A is 24. Okay, wrote that in the wrong spot. And then A is 121 degrees. So check in my checklist. I have been given two sides and one angle. Two sides, one angle. And the side across from the given angle, meaning the one with the same letter, is smaller or shorter than the other. Let's see. Is the 24 shorter than the other? Yes. So this is a two or none situation. So I just start doing my work. Sine 121 over 24, sine of angle T over 32. I'm looking for an angle, so I'll ultimately end up having to do sine inverse. So I do 32 times the sine of 121 and divide it by 24. So the sine of T is 1.14. So I'm supposed to do sine inverse of that answer. So if I do inverse sine of that answer, there it is. I got my error. That makes me pretty happy because now I just say, yeah, this forms no triangle. And that's it. That just means we're in that situation where the side across, like if you drew this, 121 is greater than 90. So there's angle A. Side T must be this one because A has to be across from it. And so even though it's 24, that's 32. And so it's not long enough to form a triangle. You don't have to be able to draw this, but for those of you who are visual, maybe that's helpful. What you need to know is, hey, I'm in this scenario and I got an error, so this one has no triangle. So that is long enough. If you need to watch through part of it again, where how do I know if there's two? What do I do? How do I know if there's none? What do I do? How do I do area? Any of that stuff. There's a lot of information in this day two. There is not a second or a third video for this. So this week, your job is to know how and when do I use the law of sines? How and when do I know if I'm going to have two or no triangles? And then just to be able to utilize that little area formula that we talked about today too. So you had one go formative, and then the worksheets that you're going to be working on. The rest of the homework for this week is all just going to be kind of practicing these trickier bits. If you have a question, let me know or pop into an optional session. See you later, guys. Bye.